In this video, we are going to look at solving both rational equations and radical equations. To begin with, here's a bunch of different kinds of equations, and we've already seen how we can solve linear ones. We've also seen how we can solve quadratic ones. So in this video, we're focusing on rational ones and radical ones. So the first principle that we'll look at today, and there's two of them, I like to call the I hate fractions principle, but you might have heard it be called the clear fraction principle. It's a really useful tool. When I learned to solve these equations, what I did is I tried to combine these two, and then once I combined them, then I used ratio proportion, cross multiply and divide to solve. And you can do that, and that works real well. But it turns out that if you are trying to solve a fraction, an equation that has fractions in it, solving using this clear fractions principle is significantly easier. So the trick is that you need to find a lowest common denominator, and then once you found that lowest common denominator, you multiply every term. So here's a term, here's a term, and here's a term. You multiply every term by that lowest common denominator. So let's first look at what our lowest common denominator for this would be. I've got a 3 and a 6. Between 3 and a 6, the lowest common denominator would be a 6. Again, remember the lowest doesn't mean the smallest number. It means the smallest number that everything can divide into evenly. So between 3 and 6, the lowest common denominator would be a 6. And there's also an x there. So my lowest common denominator would be that. So I need to include every factor the most number of times that it occurs. So now I'll take and I'll each term, and I'm going to multiply it by that. In the book, they just sort of put brackets around it and put a 6x out front. And you can do that, and then you just have to apply that to everything. I like to actually do it this way. So I rewrite my equation, and I just leave space for multiplying everything by 6x. Okay, so I'm going to multiply this by 6x, and you can call it 6x over 1. Multiply this by 6x over 1. Multiply this by 6x over 1. And now for each term, you remove common factors. So for this first one, I've got 6x times 2 divided by 3. Well, the 3 goes into the 6 twice. And then I've got 2 times 2 would be 4, and I have an x. So that first term will be 4x. Notice there's no fractions. So I'm not getting a common denominator so I can put it on every term. I'm using that common denominator to multiply every term, and then I get rid of the fraction. That's why I call it the I hate fraction rule. The next one, 6's, that's a common factor of 1, gone. So 5 times x would be 5x. And then over here, the x's cancel. 6 times 1 divided by 6 is still a 6. Collecting like terms on the left, I've got negative 1x is equal to 6. Divide both sides by a negative 1, and my answer will be a negative 6. Now you can go back and plug that in, and it's not a bad idea to do that. I'm not going to do the whole thing here, but I just want to point out one thing, that if I plug in that negative 6 right there, that fraction becomes a normal fraction. It's not something that you can't have. Remember earlier in the rational section, we talked about denominator can never be 0. And so if I put a 0 up here, that would discount my answer because it can't be 0. But my answer came out to a negative 6, so it's probably an answer that'll work. Let's try doing one on your own. So try this, press pause, play after you're ready, and see how you do. Okay, with this equation, I would put these over 1, and my lowest common denominator, since all I have is a 1 and a y, my lowest common denominator will be a y. So I'm going to take y plus 22 over y is equal to negative 13, and I'll multiply everything by my lowest common denominator. In the first one, y times y is y squared. The next one, the y's cancel, so it'll just be a 22. And then over here I have a negative 13y. Now I have a quadratic equation, so I have to remember how to solve quadratic equations. And to do that, I need to bring everything over to one side. So I'll add 13y to both sides. So there'll be a 13y here and a 22 there. Notice why I put the 13y in the middle, so it's in descending order. And on the right I have 0. And I do that so that I can use the zero principle. And I use the zero principle by factoring this side. And I just pray that it'll factor properly. So things that multiply to 22 add to 13, 11, and 2, I think. So plus 11, plus 2. Good. Now I use the zero principle. Either y plus 11 is 0 or y plus 2 is 0. So I get y is equal to a negative 11 and y is equal to a negative 2. Again, I probably should take those and just confirm. You can plug them in and work it all out to see if they're right or not. But the main thing I check on is I take this number and I look there on the denominator and see if that's legal. Dividing by negative 2 is legal, so I'm fairly confident that my answers are correct. We'll see on another problem where you might get into trouble. Okay, here's another one. This is where you have a binomial on the bottom, and you need to try and solve that. Do the same thing. I'm going to look for a lowest common denominator, and this is treated as a group. So my lowest common denominator has to include a y plus 4 and a y minus 2. So I'm going to take the 5 over y plus 4 and the 3 over y minus 2. And to each one of them, I'm going to multiply by y plus 4, y minus 2 over 1. And this one, same thing. Y plus 4, y minus 2 over 1. So in the one on the left side, you'll see that the y plus 4's cancel. So I'm left with going 5 times y minus 2. Notice I put the single, the constant term in the front, and then the binomial after that is equal to the y minus 2's cancel here, and I'll be left with 3 times y plus 4. Now to solve it, I'll use the distributive property, so 5y minus 10, more distributive property, collect like terms on the same side, so I'll bring that 3y over and make it negative, and on this side I'll take this minus 10 to the other side, add 10 to both sides. So on the left, I have 2y. On the right, I have 22. So dividing, I come up with 11. Again, good idea to check that to make sure that if you take this number and plug it in either there or there, that you don't get a 0. And 11 plus 4 is 15. That's okay. Why don't we check this one? 5 over 11 plus 4. Is that equal to 3 over 11 minus 2? Yeah, so 5 over 15, is that the same as 3 over 11 minus 2 is 9? If I simplify the left side, I get 1/3. If I simplify the right side, I also get 1/3. Therefore, my answer checks. Okay, why don't you try this one? You're going to need to factor and then come up with a lowest common denominator. That'll be a little bit of work on that one. Okay, hopefully you've tried it. First thing I would do is that second term in, I need to factor the bottom. And it's x minus 2, x plus 2 is equal to x plus 3 over x plus 2. Now to find my lowest common denominator, I need to have every factor the most number of times it occurs in any one factor. So here I have x minus 2. Here I also have another x minus 2. I don't need to write it again, but I also have an x plus 2. So I need that in my common denominator. Here I already have an x plus 2. So this is my lowest common denominator. So I'm going to multiply every term by that. I'm just going to make it real small, just so I don't have to write it out again. X minus 2, x plus 2. Again, remember these are over 1. And then here, x minus 2, x plus 2. You probably see where I'm headed here. This first one The x minus 2's will cancel, so I'm left with x times x plus 2. The next one, all of it cancels, so I just am left with plus x. On this one, the x plus 2's cancel, so here I have x minus 2 times x plus 3. Now to solve this is going to be a little bit more work, which is good. So distributive property, x squared plus 2x plus this x equals, FOIL this out, so it'll be x squared plus 3x minus 2x minus 6. Now, I was thinking it's a quadratic, but I think that these two will cancel out. Because if I subtract x squared here and subtract x squared there, they cancel out. That's nice. So let's gather x's on the left side. 2x plus x would be 3x is equal to 3x minus, be an x minus 6. I'll subtract x on each side. 2x is equal to 6, negative 6. Divide both sides by 2, and I get x equal to negative 3. Let's just go up top there and see. So if I take that number, this number, and plug it in there, or there, or there, I'm hoping I don't get a 0 on the bottom, and I don't. Again, you could plug it in everywhere you see an x, and see what, make sure the left side comes out to the right side. But on initial check, I think we're pretty good. All right, so that is the I hate fraction rule. And you use that to solve rational equations. Oh, the other thing I was going to say with that is that, yeah, you can only use that if it's an equation. If it's not an equation, you can't use it. Okay, let's turn our attention to radical equations. And for these, we use a principle called the power principle. And that allows you to get rid of something that you don't want. Like in the last section, we were wanting to get rid of the fractions. We used I hate fraction rule. The power principle allows us to get rid of radicals. So here I've got an equation I want to solve for x. You might be able to take a look at it and say, well, the answer has to be 78. If you could do that, that's pretty impressive. I can do it just because I've done this question before, so I know what the answer is. But in order to solve it, it's fairly straightforward. I use this power tool or power principle. And what that says is that if you have a radical that's isolated, what you can do to get rid of that radical, so this is the fourth root, you just have to raise that to the fourth power. So let me just rewrite it. So I have this, and so I'm going to raise this side to the fourth power. And what that does is that cancels out the square or the fourth root. And so on the left, all I'll be left with is an x plus 3. But like any other rule, you got to apply that to everything. So if I raise the left side to the fourth power, I also have to raise the right side. 3 to the fourth, I think, is 81. Now to solve the equation, I'll subtract 3 on both sides. 81 take away 3. Sure enough, your answer came out to 78. So that's a power rule. And we can use that a number of different ways. Let me show you a couple more examples. So this one here, I've got a radical, plus 5 equals x, and I want to solve for x. I've got two x's, one problem. But one issue that I have here is that the radical isn't isolated. And what I need to do is I need to isolate that so it's on one side of an equation and all the other stuff is on the right side. So my first step here is to subtract 5 on this side, subtract 5 on this side. Okay, so now I've got root of x minus 3 is equal to x minus 5. Now I have that radical isolated. Now I can use that principle or the power principle. So I'll take this side and I'll square it. If I do that, I also have to square this side. Notice I'm squaring a binomial, so you have to be careful with that. And I'll show you how to deal with that in a second. But you can't just square the x and square the 5 and call it good. You've got to actually FOIL something out. Okay, so the square and the square root cancel, leaving me with just x minus 3. And then on this side, I've got to write out 2 of these and then distribute, FOIL that whole thing out. So it'll be x squared minus 5x minus another 5x plus 25 is equal to x minus 3. I've got a quadratic, so I'm going to bring everything to the right side, and then hopefully I can factor things. So I've got x squared. This will be minus 10x. If I bring this over, it'll be another minus x. Then I have a plus 25. If I bring this over, it'll be a plus 3. So now I'll have 0 is equal to x squared minus 11x plus 28. I sure hope that factors. Otherwise, we get to use a quadratic formula. 7 and 4. Ooh, that was beautiful. Okay, and so now the 0 property, x minus 7 is 0, so x is equal to positive 7. Or x minus 4 is 0, in other words, x is equal to 4. Now, with square roots, I always like to check both of these, just because I've got to make sure that what I plug in there is going to actually work. And I guess with the other equations, typically things work, but with these ones, often I find that there's one or sometimes both of the answers that don't work. So I like to check them both. So square root of x, let's try 7 first. So 7 take away 3 plus 5 is equal to x, we're working on 7. 7 take away 3 is 4. Square root of 4 is 2. 2 plus 5, 7. Good answer. Let's try the next one. So root of 4 take away 3 plus 5 is equal to 4. We're working on. 4 take away 3 is 1. Square root of 1 is 1. And 1 plus 5, not equal to 4. Therefore, I would cross that answer out as not being an answer. So the only answer that works for this question is 7. Okay, sometimes you get an equation where you have two radicals, and this one's not for the faint of heart, but let's try and see how we do. If there's two radicals, I use the same principles. It's just that it gets a little bit messy, as you'll see in a second. First thing, I need to isolate one of the radicals. I'm going to isolate this. So I'll add root y minus 2 to both sides. So I get root 4y plus 1 is equal to 3 plus root y minus 2. So I've isolated one of the radicals. Now I'll use the principle of powers. So I'll square this side. And on this side, you have to square that whole thing. You can't square them individually. Left side, those cancel. 4y plus 1. I'm breathing a little bit easier because I just have one radical now. But on this side, I need to write both of these out and then FOIL them. So 3 times 3 is 9. 3 times that will be a positive 3 root y minus 2. The next one will be plus another 3 root y minus 2. And lastly, root y minus 2 times root y minus 2, let me do it over here. Root y minus 2 times root y minus 2 is the same as root of y minus 2 squared, that's a 2, and the 2 and the square root cancel. So the answer to that part is just y minus 2. So plus y minus 2 equals 4y plus 1. Okay, now I've got a bunch of stuff here. What I probably want to do is collect those radicals and isolate them. So let's move everything over to the left side that's not a radical. So 4y plus 1, move this over, minus 9. Move this over, minus y. Move this over, plus 2. Is equal to, if I add those together, that becomes 6 root y minus 2. Okay, collecting like terms on the left side, it looks like I'll have 3y. 1 take away 8 is negative 8, plus 2 would be a negative 6, is equal to 6 root y minus 2. Now, I know I want to isolate the radical, but here, if I divide both sides by 6, I'm going to get a fraction on this left side. So I might just leave it as is and just square things as they sit. Okay, so square this side, square this side. On the left side, I'll have 3y minus 6 times 3y minus 6. On the right side, I'll have 36, and then the square of this cancels that, so that'll just be y minus 2. Okay, more paper. FOIL the left side, 9y squared minus 18y minus another 18y plus 36, right on. Distribute property here, 36y minus 72. Look, no radicals, right on. I've got a quadratic, so let's bring everything to the left side. So I'm going to have 9y squared. This will be minus 36y. If I bring this over, that'll be another minus 36y. And then I have a plus 36. I bring this over, it'll be a plus 72 is equal to 0. Okay, collecting like terms, 9y squared. I'll be amazed if this works. Minus 72y, add these things, that's about 108. Not about, it is 108. Quadratic, I wonder if I can take a common factor and 9 out first. I think so. So let's divide everybody by 9. Notice everything, including the right side. So I'll just have y squared minus 8y plus, what's that, 112 is equal to 0. Almost done. Two things that multiply to 12 and add to 8. I'm thinking 6 and 2. Is that right? Y squared minus 2. Yeah, that's right. And so to solve zero property, either y minus 6 is 0 or y minus 2 is 0. So y is 6 or y is 2. Okay, so 6 and 2 are my answers. Let's just go back up and check to see if either of those will work. 6 and 2, boy, that's a lot of work. Okay, I'm just going to try and visually do this, or mentally do it. 6 there. 4 times 6 is 24 plus 1 is 5. 25 squared of that is 5. I'm putting a 6 in here. 6 take away 2 is 4. Square root of 4 is 2. 5 take away 2 is 3. Yes, 6 works. Let me just go down and say that. 6 checks out. Let's try 2. Okay, so this time if I put a 2 there, 4 times 2 is 8 plus 1 is 9. Square root of 9 is 3. I'm putting a 2 in here this time. 2 take away 2 is 0. Square root of 0 is 0. 3 take away 0 is 3. Yeah, that one's right too. So both those answers that I had down here are correct. That's a tough question. Lots of places where things could go wrong. Why don't you try that one? It's not the same as the last one, but the one before that. Try that, pause it, press play, see how you do. All right, first thing I would isolate the radical, so subtract 5 on both sides. X take away 5. Then I'll use the square or the power principle, square both sides. I'll have x plus 7 is equal to, when I FOIL that, I'll get x squared minus 10x plus 25. Gather like terms, let's bring this x over and subtract it. So 10 take away 1 will be a negative 11x. And I'll subtract 7 on both sides, so that'll be 18 plus 18 equals 0. And then factor. Two things that multiply to 18 add to 11. I'm thinking 9 and 2. X minus 9, x minus 2. So using the zero principle, I'll get x is equal to a positive 9 and a positive 2. Let's just confirm which of those hopefully will work. So if I put a 9 in right there, 9 plus 7 is 16, square root of 16 is 4, 4 plus 5 is 9, checks out. Let's put a 2 in. 2 plus 7, so I need to put a 2 there and there. 2 plus 7 is 9, square root of 9 is 3, 5 plus 3 is 8. It's not 2. 2 can't work. So the only answer is 9. All right, so in this module, we have looked at, or in this concept, we've looked at two principles that you can use to solve different types of equations. So the I hate fraction principle you can use if ever you've got a fraction, whatever, if ever you have a fraction and an equal sign. So there has to be an equal sign. You can use that and immediately your fractions are eliminated. And then we also looked at the principle of powers, and that's a way of getting rid of a radical in an equation so that you can solve for your x's. Okay, try the video quiz and then try some homework.